So the first measure we're going to talk about here is the mean, which in this context we call the expected value. And I said the word expectation a few times when we talked about means back in chapter 2. That's because in here, that's how we talk about it. That if we're going to look at some event governed by a probability, we want to find what we should expect to happen from any given run. That is, we want to find the expected value, where that expected value takes the role of the mean. And in particular, the mean that we're computing here is much the same as the weighted means that we saw back in chapter 2 as well. So for a quick example of how this works, let's go back to our old friend, the six-sided die, where if we want to think about what the average from a six-sided die would be, that is, the average die roll, well, we would compute something like a weighted mean. So we'd have mu, we're going to call that E of x for the expected value here, follows the formula of the values x multiplied by its weights. Excuse me, let me get this right because that technically goes on top divided by the sum of the weights. It's been a while since I wrote the formula for the weights, and here it's kind of silly because what's going to happen is we have our values, and straighten that out just a little bit more, where those are 1, and I'm going to leave some space there for a reason, 2, 3, 4, 5, and unfortunately 6 is going to land over here. And each of the weights associated to them is 1/6, because we're proceeding classically, that each of the dice rolls are equally likely. So you've got a whole bunch of things multiplied by 1/6, and then divided by the sum of the weights, but all the weights are the same. It's just 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6. So we've got 5 of them, we need one more, 1/6. So when we're talking about this, oh, I did want that one actually. The sum of the weights just ends up being 1. So the bottom, just dividing by 1, that's not really doing anything. And on the top, we would just end up with 1 times 1/6, so 1/6, plus 2/6, 3/6, 4, 5, and 6/6. It's hard to say, but we could condense that down to 6 underneath 1 plus 2 plus 3 plus 4 plus 5 plus 6, which would end up being 3, 6, 10, 15, 21/6, or 3.5, where in particular, we could have seen that this came from the sum of our values multiplied by their associated probabilities, which is our formula for computing an expected value. And next, we're going to see a, let's say, less classical example for how this works.